You know, many of us remember a time when the mere mention of German engineering meant power, precision, and technological supremacy. They were the ones who brought the world V-2 rockets and the terrifying early jet fighters. Yet here is a piece of history suggesting that even the sharpest minds can be blinded by arrogance. We have to understand what was happening in the midpoint of the Second World War. The U-boat wolfpacks were not just a military threat, they were a stranglehold on Britain itself. They were sinking merchant ships faster than the shipyards could build them, threatening to starve the nation into submission. Therefore, the war was not just being fought on the battlefields of Europe, it was being fought in the dark, cold depths of the Atlantic. And this created the immense problem that the Allies simply couldn't solve. How do you find a black submarine hiding in a black ocean at the blackest hour of night? The Germans had a reason to be confident. Their top scientists, viewing early British and American radar, looked right through it. They scoffed. They dismissed it as bulky, prone to failure, and worst of all, using high-frequency signals that their U-boats could easily hear coming. They were so convinced of their technological lead and their early warning gear that they missed the one thing that would kill them all: a tiny, secret box of technology being developed quietly in Britain. Now think about that arrogance for a moment. They knew the Allied radar existed, they just believed it was fundamentally flawed. This profound hubris is the green setup, the intellectual mistake that would cost them the Battle of the Atlantic. But the Allies weren't building a bigger, clumsier version of the old radar. They were building something entirely new. They were working on a breakthrough that would redefine naval warfare. This tiny, secret weapon, a device built at the University of Birmingham, was the cavity magnetron. If you're interested in the untold stories of how ingenious technology changed the course of world events, please subscribe now. It's the best way to support our effort to bring these crucial, detailed histories to light. We've already seen the massive gap in German thinking. Now we need to know what this revolutionary cavity tech actually did. This question moves us directly into the crisis of the U-boat war itself. Therefore, to truly appreciate the genius of the solution, we must first confront the terrifying scale of the problem. 1942 was known as the Black Pit of the Atlantic. It wasn't just a grim name, it was the reality of the sea lanes where air cover, the last bastion of hope, simply couldn't reach. The U-boats held all the cards. They attacked with impunity, sinking Allied merchant ships at an alarming rate. It was a statistical horror show that threatened the entire war effort. Why? Because the sheer tonnage sunk that year was crippling. We're talking about convoys that left port full of men, food, fuel, and munitions, only for half or more of those ships to simply vanish beneath the waves. The war was reduced to a desperate math problem. Could the Allies build ships and manufacture materiel faster than Admiral Dönitz U-boats could send them to the bottom? The stakes were intensely personal. Think about those merchant mariners, just ordinary men, young fellas, many of them, facing the vast, black ocean and the icy threat that came with the sound of a distant U-boat horn. They weren't soldiers, but they were in the fight, and they were dying in droves. Now, the Allies weren't idle. They scrambled to find an answer. They tried everything: massive searchlights to pierce the darkness, elaborate escort formations, and early attempts at radar. However, the early radar systems were proving to be almost worse than useless. Many an Allied captain felt the bitter sting of failure, knowing he had spotted a U-boat on his rudimentary radar screen, only for the U-boat to dive to safety the moment it heard the radar signal approaching. That led to tremendous frustration. They knew the enemy was there, yet they were powerless to stop it. It was like shouting your location to a hidden enemy. This is where the grand strategic ambition of Admiral Dönitz comes into chilling clarity. and it gives us the number we must defeat. Dönitz was explicit. He needed to sink a combined 50 U-boats monthly. That's 10,000 tons of shipping every day to break Britain's will and cripple the Allied flow of supplies. He believed he was on the cusp of achieving it, and for a long, terrifying time, he was right. This incredible scale of loss sets the stage for the next part of the story. The Allies had to find a secret that the Germans simply could not answer, because the current technology wasn't just failing, it was actively betraying them. But the grim arithmetic of 1942 begs a far deeper question. Why were the Allies unable to fight back with the tools they already possessed? They had radar, a revolutionary technology born of scientific genius, yet it failed them time and again. The issue lay with the very nature of the early radar systems used, specifically the high-frequency radar. Think of it like this, gentlemen. Imagine trying to sneak up on a wolf pack in the dark with a massive old-fashioned flashlight. The beam is wide, slow, and obvious. That's exactly what the early radar signals were doing. These early sets operated on long wavelengths, typically around the 1.5 meter mark. This wavelength was easily detectable by the German U-boats. Therefore, the Allied planes, meant to be the saviors of the convoys, were inadvertently signaling their arrival long before they were close enough to strike. This brings us to the chilling cleverness of German counter-technology. The U-boat crews were equipped with a listening device called the Metox receiver. This machine was designed specifically to pick up the long high-frequency wavelengths of Allied radar. As soon as the radar beam from a distant patrol plane hit the U-boat, the Metox would start shrieking, giving the crew a precious few minutes of warning. Imagine the crushing irony. The device meant to provide the Allied air crews with a vision advantage was instead acting as a high-tech alarm bell for the enemy. History suggests this deadly technological flaw was responsible for a substantial number of unexplained U-boat escapes and the devastating loss of many Allied aircraft that flew right into the line of fire. Because of the predictable radar frequency, the U-boat wasn't just avoiding detection, it was actively preparing for the attack.
The German U-boat command grew confident, even arrogant, in their electronic superiority. They assumed that radar technology was confined to these long, high frequencies, and their Metox defense was foolproof. This overconfidence was their great undoing. It was a failure of imagination rooted in a tactical assumption that the wavelength the Allies were using was the only practical one available. Now, why couldn't the Allies simply change the wavelength themselves? This is the technical lock that needed a revolutionary key. Generating powerful, short-wavelength radar signals too fine and fast for the Metox to hear, was beyond the scope of existing technology. It would require generating an immense amount of microwave power from a device that could actually fit inside a small patrol bomber. The solution needed was literally too small and too powerful to believe. The Allies knew they needed a silent, unseen shield. They needed a technology that didn't just illuminate the night, but one that was completely invisible to the enemy. That need moves us directly from the battlefield reality of the Atlantic crisis to the secret laboratory where the counterweapon was born. The answer wouldn't be found in naval tactics, it would be found in a physics laboratory. But while the courageous men of Coastal Command wrestled with ineffective, often treacherous HF radar in the deadly Atlantic, a small, quiet miracle was taking shape in a British laboratory. The solution to the U-boat crisis wasn't going to be a bigger ship or a better bombing run. It was going to be an almost impossibly small piece of hardware that would change everything. This pivotal device, born from the collaboration of scientists John Randall and Harry Boot at the University of Birmingham, was the cavity magnetron. This wasn't just an improvement, it was a revolution. Until then, generating powerful, stable microwave signals, the kind needed for radar that could see small objects without broadcasting its presence, was the major bottleneck. Existing vacuum tubes were bulky and couldn't produce enough power to make the tiny centimeter-wavelength radar practical. The magnetron shattered that barrier. It was a copper block drilled with a ring of resonant cavities that, when energized, generated microwaves with immense power, thousands of times greater than previous systems. Think of it as the difference between trying to throw a bucket of water at a target and being able to unleash a concentrated fire hose. This tiny device was the secret key that unlocked the microwave frequency band for Allied radar. This shift to centimeter wavelengths, moving the radar frequency from meters down to mere inches, was a true game-changer. Why? For two critical reasons many of us who follow military technology understand. First, the short waves allowed for radar antennas small enough to fit easily inside the nose of an aircraft, making aerial installation practical. Second, and most crucial to the Battle of the Atlantic, the German METOX receivers were completely deaf to this new, super-high frequency. Therefore, the U-boats were rendered blind. The Germans had been relying on the fundamental properties of the long, high-frequency waves. When the Allies suddenly jumped to a wavelength they hadn't anticipated, they became completely invisible. The new radar didn't just spot the U-boats, it did so in complete silence, giving no warning whatsoever. The brilliance of this invention was its simplicity and its sheer power. It allowed Allied aircraft to carry the equivalent of a powerful, long-range searchlight that the enemy couldn't detect, all housed in a small, self-contained unit. History suggests this single technological leap, delivered in a little box from a lab in Birmingham, was the most important weapon of the entire war. This new radar technology would be packaged into the ASW Air-to-Surface Vessel Radar Set Mark III. The stakes were so high that this technology became one of the few British military secrets immediately and fully shared with the United States. If you've been following along, you already know the danger was urgent. The Allied scientists weren't just working for a military advantage, they were working for survival. This pivotal moment in the technological arms race ensured that the upcoming battle would be fought on Allied terms in a frequency band the Germans didn't even know they needed to listen to. The days of the U-boat receiving a chilling METOX indication were about to end. The question now shifts from the laboratory to the field. How was this potent, game-changing secret slipped into the Atlantic war zone without tipping off German intelligence? The moment the cavity magnetron was miniaturized and packaged into the ASW Mark III radar set, the problem shifted from the laboratory to the field. How do you deploy a war-winning secret without alerting the enemy? The answer lay in a masterclass of military deception orchestrated in the shadow of a major upcoming campaign, Operation Torch. Operation Torch, the Allied invasion of North Africa in late 1942, provided the perfect cloak. It was a massive undertaking, and within that vast logistical shuffle, the new radar sets could be secretly slipped onto Allied aircraft, particularly the Vickers-Wellington bombers of Coastal Command. But here's the genius of the deception, and this addresses the great anxiety felt by Allied commanders. They couldn't just swap out the old, failing HF radar. If German reconnaissance detected that the familiar radar array had vanished from Allied planes, they would immediately deduce that a new, secret system was in play. Therefore, the Allies had to make the Germans believe nothing had changed. The engineers performed a subtle but brilliant maneuver. On many of the patrol bombers, they left the external antenna and fittings for the old, easily detectable HF radar visibly installed. It looked exactly the same to a U-boat crew member observing from afar or to a German intelligence photo analyst. The old system was still there, broadcasting its low-frequency signal for anyone with a METOX receiver to hear. However, deep inside the aircraft, the real change was taking place. The compact ASW Mark III, the radar powered by the cavity magnetron, was running silently, its centimeter-wavelength signals requiring only a small, unobtrusive antennae hidden beneath the fuselage or within a protective radome. This was the ultimate quiet killer. The hunter was now operating in a frequency band the hunted didn't even know existed. The effect was instantaneous and, frankly, terrifying for the Germans. The green setup here is the mystery. Allied aircraft were suddenly seeing U-boats on the surface at night, in thick weather, with no warning given. The U-boats were being attacked at point-blank range, often just as they were charging their batteries or exchanging messages on the surface, the times they were most vulnerable. History suggests that the first use of the Mk3 was almost unbelievable to the air crews themselves. After years of the feudal cat-and-mouse game that always favored the U-boat, they were suddenly seeing clear, definite radar blips of the enemy at night. The purple payoff was the utter surprise. The METOX receiver remained silent. The U-boat captains, who had relied on their technology for their very lives, were blind. The tactical advantage was monumental. The U-boat's two primary modes of defense, the long-range warning from METOX and the speed of diving, were negated simultaneously. They were being spotted while they were most exposed. This secret deployment wasn't just about sinking a few subs. It was about shifting the entire axis of the battle. It meant that the technology that Dönitz had scoffed at, radar, had been secretly upgraded and deployed with such mastery that his entire defense system was rendered obsolete overnight. This moment represents the true victory of British and American scientific collaboration, a testament to the fact that wars are won not just by brave men, but by brave ideas. This technological blindness leads directly to the catastrophic surge in German submarine losses, bringing Admiral Dönitz's war machine to the brink of collapse. The introduction of the ASW Mk3 radar created an agonizing puzzle for the German High Command. Admiral Dönitz, whose U-boat tactics were based on flawless coordination and stealth, suddenly faced a terrifying mystery. The green setup was simple. Why were his U-boats vanishing without a trace? The losses weren't just mounting. They were happening under inexplicable circumstances. U-boats were being attacked at night, in the worst weather, and often when they were cruising on the surface, the time they should have been safest, protected by the darkness and their METOX warning system. The U-boat captains were reporting no radar detection, no visual sightings, just the sudden roar of engines and the immediate deluge of depth charges. This created what we can only call the Dönitz panic. He suspected everything but the true technological reality. He poured resources into counterintelligence, believing the Allies had somehow cracked his codes or placed spies in his bases. He even surmised that slow-moving Allied surface ships were secretly carrying sub-spotting helicopters, a crazy notion at the time, yet one that speaks to his total confusion. But the German error was rooted in a fundamental miscalculation about the limits of Allied science. The purple payoff was the realization that the Germans were trying to solve the wrong problem. The METOX receiver was still functional, but it was listening in the high-frequency band, which only picked up the old, easily detectable Allied radar. The new centimeter-wavelength radar, powered by the cavity magnetron, was operating in a band that the METOX couldn't hear. It was like trying to listen for a whisper on a completely different radio frequency. The tragedy for Dönitz was compounded by the tactical reality of submarine warfare. U-boats had to surface to recharge their batteries, ventilate, and travel at maximum speed. They relied on the blackness of night for this vital period of vulnerability. Therefore, removing their ability to use the surface safely at night broke the fundamental rhythm of the wolfpack. The impact was measurable and devastating. In just a few critical months in the spring of 1943, the rate of U-boat sinkings soared, finally exceeding 50 U-boats monthly, the very threshold Dönitz needed to win the war. The Allies had flipped the script, achieving the impossible benchmark in reverse.
This compelled Dönitz to take the unthinkable step. He was forced to temporarily withdraw the wolfpacks from the main North Atlantic convoys. It was a tacit admission that the battle had been lost, or at the very least, that the balance of power had shifted irrevocably. The sea lane of supply, the one great choke point of the war, was, for the moment, clear. We must remember the sailors who achieved this victory. It was the air crews, working in terrible weather, who were finally given the tool to level the playing field. Because of the silent sight of the Mk3 radar, they were able to reverse the tide of war, securing the crucial supply line that made the upcoming invasions of Europe possible. This was science delivering salvation on a global scale. Therefore, this massive tactical defeat forces us to examine the long-term impact of that scientific secret, from the skies above the Atlantic straight into our modern lives. Having witnessed the devastating reversal of fortune in the Battle of the Atlantic, a victory hinged entirely on a scientific secret, we must now consider its final destiny. The cavity magnetron was more than a war-winning weapon. It was a technological key that unlocked a new realm of physics and, astonishingly, found its way into almost every home. The green mystery is this: how did a device so critical to national security, a technology once guarded by Coastal Command and the highest levels of military intelligence, transition from sinking U-boats to heating up TV dinners? The answer lies in the intense military investment that pushed microwave technology past all previous commercial or academic limits. The sheer power and stability of the microwave signals generated by the magnetron were unmatched. After the war, when the German High Command finally realized the full extent of the technological leap the Allies had made, the shock was immense. Their arrogant assumption that high-frequency radar was the end of the line proved catastrophically wrong. The centimeter-wavelength radar left them utterly blind. The purple payoff was the realization that this secret weapon became the foundation for a peacetime revolution. The Allied scientific exchange, which had been so vital to sharing the magnetron's design during the war, continued to inform post-war industrial research. Defense contractors, eager to leverage their wartime knowledge, began experimenting with the device for industrial and then consumer applications. This meant the core component of the ASW Mk3 radar, the device that silently tracked and doomed the wolfpacks, found new purpose. That microwave oven that sits in your kitchen today, heating up last night's leftovers, works because of the same principle developed in that urgent laboratory race. The magnetron in your microwave works by generating those intense, short-wavelength electromagnetic waves originally intended to spot a steel periscope on a dark and stormy sea. Think about that moment of historical transfer. The power needed to win a global war, distilled and packaged for domestic convenience. It's a remarkable fusion of military necessity and civilian comfort.
This technology didn't just fade away. It was adopted, adapted, and popularized, becoming one of the clearest examples of a military invention having a profound and lasting civilian impact. This magnetron's legacy can also be seen in countless other modern applications, from telecommunications to industrial heating. Therefore, the story isn't just about a turning point in 1943, it's about a foundational piece of technology that is still actively shaping our daily lives 80 years later. It reminds us that necessity truly is the mother of invention. If you appreciate how deeply history influences our present, please leave a comment below sharing the most surprising World War II invention you know. It helps us keep the channel community lively and engaged. We've seen the problem, the technology, and the legacy. Now let's close the ledger on the Dönitz panic by looking at the final, crucial numbers that determine the winner. We come to the final, necessary chapter of this dramatic shift in the Battle of the Atlantic, the ultimate tally that closed the book on the Dönitz panic. The green curiosity is precise. What was the measurable, undeniable impact of this single technological shift? To appreciate the purple payoff, we must first look back at that chilling benchmark set by Admiral Dönitz. His analysis was simple and brutal. He needed to sink 50 U-boats monthly to break the Allied supply line and ensure German victory. For months, the Allies were losing. The average tonnage sunk by U-boats was devastatingly high. But everything changed with the silent deployment of the ASW Mark III radar in early 1943. The impact of the cavity magnetron was not theoretical, it was an avalanche. The U-boats, suddenly blind to the approaching anti-submarine aircraft, became easy targets. In May of 1943, history was rewritten. The month saw the sinking of 43 German U-boats, a number that combined with operational losses signaled the end of the war's most critical period. The Allies had not only denied Dönitz his 50-sub victory threshold, they had reversed the equation. Now, think about that number. 43 U-boats sunk in a single month, primarily due to air power, armed with this new radar. The following month saw the rate remain catastrophic for the Germans. The victory was secured not just by sinking subs, but by the psychological warfare unleashed by this unseen technology. The U-boat crews lost faith in their ability to survive, and Dönitz lost faith in his strategy. Therefore, he issued the agonizing order to temporarily withdraw his forces from the North Atlantic convoy routes. This single act, the retreat of the wolfpacks, was the true victory. It meant the Allied supply lines, choked for years, were finally opened wide. Fuel, food, troops, and munitions flowed freely to Britain, enabling the crucial preparations for Operation Torch and eventually the Normandy landings. The entire fate of the war, hanging precariously over the black pit of the mid-Atlantic, was secured by a tiny, powerful piece of British engineering. The final scorecard is a testament to the brave men of Coastal Command, who after years of flying into death traps were finally given a chance to fight back on silent, unseen terms. They secured the essential premise of the war, that the Allies could project power across the ocean without being strangled by the enemy beneath it. We must always remember that the battle was won by the quiet courage of those crews and the brilliant ingenuity of the scientists who gave them the tools they needed. If you want to keep exploring the deep secrets of World War II's technological turning points, look for related content here on the channel. It's a vast, rich history, worth exploring.